Okay, let's begin. So I'm assuming everyone has like code up till here written down, right? Sorry? Okay, then do it. So this, okay, yeah, it's okay. So this we're just like getting all the libraries and the functions that we need for our project to our code, okay? Then do you remember like any of this? Data collection, pre-processing, visualization, splitting. This is also in a PDF that I sent to all of you. We did this, I think, on the second or third day. The machine learning workflow. Do any of you remember? Okay, so this is basically how we, like the steps we perform to finish a project. The first step was data collection. Does anyone remember what that was? Just getting the data from different sources, right? Then we have pre-processing. Does anyone remember what that was? It's basically when we look at our data and we try to figure out, oh, what model we have to use or what are the relationships between data. So do you think we've like done both of these up till now? Right? We have looked at correlation heat maps and we've looked, sorry, this is correlation heat maps will be visualization, which is when we look at all the data and we look at, oh, this is like, this is how they're correlated. If one increases, the other one increases like this. So do you think we've done visualization? Do you think we've gotten the data, student performance.csv? Right, so we've done this. We've done pre-processing. Remember I asked you to change the names or like rename. You all found out the dot rename function, right? So that's pre-processing. That's doing something with the data, changing a little bit of things, right? Then we've also done visualization. We've plotted the data using a pair plot and a correlation heat map. Then, okay, so now we come to splitting. But before that, there's one more thing we need to do. Okay, before we, do you remember what splitting was into training and testing data? Splitting into training and testing data. So when we give our data to the model, we don't give all of the data, right? We leave some so that we can test it later. I gave an example of like if you have to teach 100, like if you have to teach kids about what different fruits are, and you show them, and you have 100 pictures with yourself, and you show them 80 pictures first of like maybe like two fruits, let's say apples and oranges. You show them 80 pictures, and with the rest of the 20 pictures, you try to see, like you give them time to learn. Yeah, come in. Yeah, with the so with the first 80 pictures, yeah, with the first 80 pictures, you're trying to like make them learn, and like you're trying to teach them what fruits look like. So what are apples, what are oranges? That's the first 80 pictures. Then you don't show them the last 20 pictures. With yeah, okay. With the last 20 pictures, you're a little bit like, okay, now I will test them. Now I will test to see how much they've learned. So that's basically splitting our data into training and testing, right? But one thing we need to do before this is we need to decide what columns we want to use for training and testing. So now you know two variables have like the strongest relationship between them, right? We just found out it was previous scores and performance index, right? So we should primarily use like both of these in our training, but there's also one more thing we need to do, right? So for linear regression, all of our input data has to be numbers, right? It has to, are like most of you confused because I don't think I've seen you for like a lot of days. So what's the last thing you remember? Do you remember coding at all, or did we not get to the coding part? We did not get to the coding part? Regression, and okay, that's still good. So regression is basically, regression was, can anyone else tell me what regression was? Regression versus classification. Sorry? Yeah, so we, this is what our data looks like. Let's just say it draws a line, and then we try to predict like new, based on this line, we try to predict new data, right? So we're basically implementing linear regression in code. Okay, so can you open Jupyter Notebook on your devices? Yeah. So, yeah. So one more important thing that we need to do before giving, like dividing our data into training and testing, is we need to deal with, there was one column which was not an integer. And we've been talking about that column a lot. What was that column? It's not an integer. Extracurricular activities, exactly. So we need to make extracurricular activities into an integer. So for that, we use something known as a label encoder. Because extracurricular activities, the 0 and the 1, this is a label. So either you've not done any extracurricular activities or you've done extracurricular activities, right? So this is a label. We need to convert this into an integer. Okay, so I assume like you've all imported these libraries. Okay, then I will come to you guys in a second. Let me just give them something to work with. Okay, then yeah. So actually, since you guys are the data scientists here, like I'll give you the option. Do you want to keep extracurricular activities or do you want to remove them entirely? Do you want to like go through this entire process of like changing their zeros and ones to, you want to? Okay. So yeah, so for that we will have, okay, now it's very convenient to use sklearn because it already has all the functionality we need. We just need to use it. So it already has a label encoder. All we need to do is use that label encoder somehow. So for that we will create a new variable. Wait, let me, if all of you like open Jupyter Notebook, then open like any file that says someone's name underscore batch 1 or batch 2. Like the ending should be batch 1 or batch 2 dot whatever the extension is. Okay, so we'll have a new variable encoder which takes in, which stores our label encoder that we've gotten from this function. So label encoder, okay, this is a new variable that's taking in this label encoder and storing it here. Okay, then okay, yeah. So if you search up this label encoder function, you will see that inside like this piece of code, we can use a dot fit underscore transform function. Okay, see again I'm talking in the language of functions. These functions you can find on the internet, you just need to know how to use them, right? So there's this dot fit underscore transform function that we'll be using. Okay, so remember how we did the data.drop? We took a new data set called data underscore copy, and then we added all the columns except extracurricular activities. So for this one, okay, we will access its, so this is the name of my data set, data, and then we will access extracurricular activities. And then we will, sorry, we will make this column equal to, okay, data, sorry, encoder, which is this variable which has our label encoder, encoder dot fit underscore transform, which is our function, and then in brackets I'll just give this column again. Okay, I know this is a little bit like what is going on, right? Because you guys are all first-time programmers, but this is like the way to use this function and everything. You can all find it on the internet. Even I don't remember all of this, right? Even I'm like looking at the code and then writing because I don't have to remember all of this. All I need to do is like understand what it means and how to how to search for it on the internet, right? So do you understand what this means? That in there's this new column data, the extracurricular activities, we're changing it using our encoder, which is a function that people use to change categorical variables, that's like 0, 1, if there are categories, even if we had a column called cat and dog, this would be a categorical variable. So if we wanted to change this into numbers, we would use something like this, LabelEncoder. So in our column extracurricular activities, we're changing this to be a transformed column which has numbers instead of zeros and ones. Okay, this is a little bit complex. You can even skip this step if you're not comfortable with this. But like you guys were curious, so I gave you the code for this. Now, can you implement this? Can you write this code? This is optional though. This is optional, so we can also move on. Okay, after you're done with this, let me just tell you like more stuff so that everyone has something to know. So when you're done with this, now we have all our columns. Remember, when we train, this is for everyone, even you guys can understand. So when we train our model, do we give the labels or do we not give the labels? We give the labels. But how do we like tell the model that this is a label, this is what you have to predict? So we have x and y values. Okay, we give the model the x and y values separately. So we'll have one data set which will have all the x columns. So, okay, can someone tell me the names of the columns? The names of the columns are studied, previous course, sample question papers practiced, and but performance index is what we're trying to predict, right? So performance index will be a y variable. Okay, so we now we need another data set that has performance index separately and all the other columns separately. Okay, so in y, let's store data performance index. Let's store this in y, and then in x. Okay, this is your job. You have to find out a way to store all the columns except performance index. We've used the dot drop function before, right? Use the dot drop function to in the x variables. You should have everything except the performance index. Okay. Or did you run all the cells? Try to run them again. Go to the first cell and run everything. Yeah, run. Just wait. Is there an error? So there's no error, right? Because you haven't finished the sentence. So this is the entire sentence. Like this is one sentence. It didn't fit. After equal to, there's this. Sorry? Yeah, after the R2 score, there's this line, data extracurricular activities equals encoder dot fit. Oh yeah, this is also, sorry. So after this, there's this and then this. Okay. Now let me. Okay, so one second. Have you been able to open Jupyter Notebook? You have all the code, right? So do you understand any of this? Do you understand any of this? It's okay. Also, guys, can you also open Jupyter Notebook? Okay. So I'll just have to like walk you through the code briefly. So can you scroll up? So what we're doing is, okay, step number 1, data collection. So we go to the first cell. So this is how import pandas as PD and then data equals pd.read.csv. This is how we got the code, student performance.csv, right? And this is data.head is used to see the first 5 rows of our data set. So that's what we did here. So we're just looking at what the data looks like. Okay, then we wanted to know some information about data. So we did data.info. So we found out that we have like mostly integer variables, but there's one variable that's an object. That's extracurricular activities, which means it's not a number. It's a class, like cat or dog, 0 or 1. It's a class like that. That's why we did this whole thing to change it into a number. Okay, then one more very important thing to do when we're processing data is to check how many null values are there. How many values are empty, right? So because that will affect our prediction. So we're checking how many values are null. Is NA means is null. Dot, and then we're calculating the sum of that for each value, for each column. Sorry. Yeah, sum of null values. Yeah. Then we check the shape of the data. So we have 10,000 rows and 6 columns. Can you tell me what the names of the 6 columns are, looking at the data? Yeah, so these are the 6 columns, and this will be like the data that we want to train on, and our model should output performance index. Okay, so that's our y value. You understand a y value and an x value, right? Because y value is what we're trying to predict, and x value is everything that we'll give to our function. Okay, then this, okay, can you tell what this looks like just by looking at it? Data.duplicated.any.sum. Remember there was, yeah, so it gives the sum of any duplicated values, because we also want to check like that our data set does not have like the same value again and again, because that will also affect our model. Then this, I was just teaching them how to get a value. So for example, if you want to get the value at the third position for r studied, if you want to get like the third value for r studied, third value, go down, yeah, go down, so it'll be 5, right? Can you go down? Yeah. So 5. This is, so you, in the first, you use square brackets for this. Do you have any knowledge about arrays in Python? Arrays or lists, right? So it's like an array has indexes 0, 1, 2, 3, 4. Array is basically an ordered collection of numbers. So 0, 1, 2, 3, and then there's something stored in those values. So this is also like an array, but in 2 dimensions. So it has columns and rows. So in the first square bracket, you write the name of the column, and in the second square bracket you write the index number. Okay, is that clear? So okay, if I ask you to output the fourth number in the previous course category, okay, output, okay, no, wait, output 5, output 5 from sleep hours. So what will you write in those square brackets? Go down and change the code. Have the rest of you been able to drop all the values? 1 second, come. Yeah. So you have to run all the cells before now.
I have run all cells.
One second. Is there an error? There's no error. Okay, yeah. All the values except performance index. Okay. Yeah. Sorry. So that's what you have to do. So you have to, you remember we did a dot drop extracurricular activities. You have to use that function to remove performance index. So here you have to write data dot drop and like whatever you have to write inside, you have to do that. Okay. So drop performance index. Okay. Are you able to do this?
Or only we have to write that code only.
F small. Fit transform. S is small. Wait, you have to write x equals data dot drop, and then everything. So this will be data dot drop, and you have to figure out the parameters on your own. So what column are you removing? You're trying to remove performance index, and then on what axis? Then in place equals true or false. Okay. So yeah, were you able to? That's probably okay. So you have to. So whenever you start a new program in Jupyter Notebook, you have to run all the cells before, because right now it doesn't know what data is. You have to run the, because data is a variable, right? Data is the name of your data set. So it has to know that data is equal to this. So that's why. No. This is not how you run. Run all cells. Run all cells. It'll take some time. Did you get the output? Yeah, but I asked you to output 5. Yeah, so I wanted you to access this element. Yeah. No, performance space index. So yeah, so you got 5, right? So you know how to access elements, right? So then, okay, so then I was teaching them how to use functions. So all of these are basically functionalities that are already provided to us. We just have to use them. We just have to know how to use them. So actually, I asked them to find a function that is going to rename r studied with a space to, actually, this was supposed to be r's underscore studied. Can you change this? R's underscore study. I wanted to, because it's not good practice to have spaces in Python. So I asked them to find a function from the internet which will change R studied to R's underscore studied. So this is what they found out on their own. So if you just do a Google search on like how to rename columns in a data set, then you'll get this function. And then they used it on their own. So basically, like all the skills that you need are basically learning how to find the functions that you have to use and their parameters. So what are parameters? So if dot rename is your function, remember if you've worked with Python before, every function has like brackets at the end, dot rename and then bracket open close. So sometimes most of the times, these like pre-written functions, you have to write something inside the brackets. You have to give some data inside the brackets. So this is what they have to give. So for dot rename function specifically, and all of this you can find on the internet. For this function specifically, you have to give the name of the column you want, like so the old name and then the new name inside a column's bracket, and then you have to give, okay, do you want it to be like, do you want the changes to happen in data, or do you want it to happen in another data set? In place equals true. Okay, can you do before data dot rename, do a data new. Now this is a new data set I'm creating. Now try to run it. In place equals false. In place, one second. In place equals f capital. So do you know Boolean variables? Boolean, so there are integers, 1, 2, 3, 4, 5, 6. There are float, which is decimal numbers. There's string. What is a string? Letters, like many letters together, like names or any text. Yeah. Okay. Yeah, written in quotes. That's very important. Then there's another variable known as Boolean variable. This can be either true or false. Yeah, true or false. And in Python, whenever you write a Boolean variable, it should be like green like this, or like some color. It should be highlighted. So all the keywords in Python, like when you write code, you'll see that sometimes like dot rename, dot duplicated, all the function names are in blue. Then all the Boolean variables, they will always be green. And basically, this helps you check if you've written the keywords correctly. Because sometimes people write f small, but that's not a Boolean variable. F capital is what it needs to be. Okay, now print data. Now do you see that our name is still the same? It hasn't been changed. Now print data new. Instead of printing data, print data new. Now run. Mm, you can just run that particular cell also. Yeah. So here we see ours, it has changed. So in place equals false means that the changes are taking place in the new data set. Otherwise, if this was true, then even if we outputted data, the changes would be there. So this would change our original data set. In place equals true would change our original data set. Then, okay, I have to really like rush this. So this is Seaborn. Have you heard of matplotlib? It's a library that is used to create graphs. But Seaborn is another library that, like, it's more user friendly because you just have to write one line of code and it will print all the graphs. For matplotlib, you have to write like multiple lines, like X label, Y label, and all that stuff. But for this, you just have to write one line, pair plot, and it will plot all the relationships between all the different variables. So these are all these are all the columns on the y-axis, and these are all the columns on the x-axis. So these are all possible graphs that you could draw. So can you tell me where the relationship is the strongest linear relationship? This one, yeah. So can you tell me what variables we've used for this? What's the y value and what's the x value? Performance index is the y value and previous course is the x value. Okay. Then we basically found out. Okay. Then okay, this was another function that they used to remove a value, remove a column. If we want to remove a column, like extracurricular activities, we'll use dot drop. And then the parameter for this is the name of the column. And then in place, you remember in place? So in place equals false means, will the data change from data or data underscore core? Yeah, so the original data set will not change. Then axis equals axis equals 1 means that the column has to be removed, not a row. So if it was axis equals to 0, the row would be removed. Yeah, so row and column, right? Then we see our new data set, which has all the values except extracurricular activities. Go down, go down, go down, go down. Yeah. So this is a correlation matrix. So like we did SNS.pair plot, this is SNS.heat map. We've just derived a correlation matrix which tells us like how strong the relationship is. So if it's 1, it means it's very strong. If it's closer to 1, 0.92, very strong. But if it's not close, it is like 0.0059, not strong at all. Again, we know that previous scores and performance index has the highest. Okay, go down, go down. Yeah, so this is just where, so like we imported Seaborn and we imported pandas, now we're importing a new library, sklearn, which has all the machine learning code. Okay, so we're just continuing from there. Okay, hopefully, yeah. What is it showing? Performance index. Okay, wait, what was, okay, axis equals what axis? 0 or 1? Row or column? What are we trying to remove? Okay, now all of you try to do that activity. Try to use the data.drop function to remove performance index. Okay.
Column.
You can work as a team. Yeah.
Column.
Column. So what's column? 0 or 1? 1. So write axis equals 1 inside the bracket. Also, why is there this bracket? Okay. Okay, okay, got it. No, this bracket does not need to be there. The square bracket is. Wait, is it not working? Okay, just wait for it. No, no, no. And your P should be capital. So look at the previous function when we used dot drop. Look at the previous function when we used go upper, go up. Okay, go up, go up, go up. Yeah. So data dot drop. Did you use a bracket there? No, right? So you just have to use it like this. This is exactly what you do. You just have to change the name of the column. Okay. So wait. So that encoder thing, it's one line. Can you shift a little bit? Okay. So this encoder thing is one line. I didn't have space on the board, that's why I had to. Okay, so Python is also space sensitive, so it will take spaces as some code. Okay. Like spaces hold some meaning to it, so you can't just add spaces everywhere. Okay. Then why? Okay, shouldn't this be in string? So just look at the previous. Okay, we use data.drop here, right? You just have to use it exactly like this, but instead of extracurricular activities, you need to have performance index. Okay, x equals data.drop. Now see like that, this is so different to that. Try to make it like that. Your y is right, so yes. Okay, so this we can do in another new column so that we can see the output. Okay. See, you can always look at the previous code you've written. You don't need to remember all of this. So if you
How
see
you have copied?
data.drop, this thing.
No, you have copied that. Copy.
No, no, I'm just separating this in different cells. Right, so just to see where the error is. Is it here or is it here? So it's here. Is equal to encoder.fit underscore transform. Label encoder is not defined. Did you run all the previous cells?